Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the A-level mathematics subject of proportion. So what is it for two variables to be proportional to each other? So we could say in our company the staff costs C are proportional to the number of people that work here. We write C is proportional, this sign means proportional to N. When we double the number of people, we double the cost. When we triple the number of people, we triple the cost. When we halve the number of people, we halve the cost. This is broadly plausible, but it does suggest that everyone is paid the same. Algebraically, we can express this as C equals S times N, which would be a straight line graph going through the origin. If you plotted N as the x-axis and C as the y-axis, then S would be the gradient, playing the role of M here in the straight line equation. And of course C is 0, the y-intercept is 0. What is it for two variables to be in inverse proportion? So, say in our company the number of free drinks that each person gets is in inverse proportion to the number of people that work here, N. So we'd say D for free drinks per person is proportional to 1 over N. So when we double the number of people, we halve the drinks they get. When we triple the number of people, they get a third of the drinks they used to get. So this would basically mean that the company always buys the same number of drinks regardless of how many people work there. Algebraically, we write this as D equals F times 1 over N. So D is the number of drinks per person, F is the number of free drinks, N is the number of people, or F over N. D equals F over N. So this would look like a hyperbola. If you drew it, and we're going to look at some now, with D as the y-axis and N as the x-axis, it's a hyperbola. And the parameter f tells us how close the hyperbola comes to the origin. So the smaller the parameter, the closer it comes. Here are some hyperbolae. And so this is a smaller parameter, this is a bigger parameter. As we get close to x equals 0, they go right up to infinity. So here's one last example, which is basically what we're trying to show here is that if x is proportional to y and y is proportional to z, then x is proportional to z. So the number of cars in the car park is proportional to the number of employees of our company, and the constant there is 0.5. So what we say is, for every one car, there's two people. This means that the number of cars in the car park is also proportional to staff costs, because we've already seen that staff cost is proportional to the number of employees. And if the constant of proportionality between number of employees and total staff costs is 40k per person, then the constant of proportionality between cars and total staff cost is 80k per car. So that's kind of how you can work out the constant of proportionality. So let's say if x is proportional to y with constant a, and y is proportional to z with constant b, then x is proportional to z with constant ab. That's the general idea. Thank you. I hope you like this video. If you do, please hit the like button. You're very welcome to subscribe and hit the notification bell. I'd love to hear your ideas. And most importantly of all, I hope you enjoy your mathematics.